Hi everyone, the focus of this video is to build an XGBoost model using Snowpark ML end-to-end. My name is Sika Das and I'm a senior architect on the machine learning field CTO team. So in order to demonstrate these capabilities, I'll walk through a scenario to predict the price of diamonds given different qualitative and quantitative attributes. In this first notebook, we will walk through the data ingestion portion. So we will read in the input data from an external stage, do some data cleaning on top, and then write the final clean data to a Snowflake table. Okay, so first we'll import some of the needed libraries. We're importing Snowpark, as well as some data science libraries like NumPy here. Next, we will create the Snowflake connection, and you can see the connection has been established. Now we will use the Snowpark data frame reader in order to read in this diamonds data set from the external stage. And so we can see here that it has been read in, and we can take a look at a quick view of what the table looks like, as well as some descriptive stats about it. Now we can go ahead and do some data cleaning. So first, we're going to force the headers of our columns to uppercase using Snowpark data frame operations, really just to standardize so that the columns are all standard when they're written into a Snowflake table later on. Then we'll do some standardization of category formatting for one of our columns called cut, just to make sure they're all uppercase and there's no spaces in between, so it'll be easier to process later on. Finally, we'll do some casting of decimal types to double type, just for precision purposes, again, to make our life easier later down the line. And then we'll write the clean data to a Snowflake table. Now let's switch over to the second notebook. So in this notebook, we will walk through a few transformations that are included in the Snowpark ML pre-processing API, and we'll also build a pre-processing pipeline to be used in our third notebook when we go through the ML modeling portion. So to begin, again, we import all the necessary libraries, Snowpark, all the different pre-processing functions from the Snowpark ML library, as well as some metrics like correlation, which we'll also compute, and include some additional data science libraries here, pandas, NumPy, and matplotlib, and seaborn for visualization. So let's go ahead and get those imports in. And again, we will establish a connection to Snowflake as before. So now we can basically input the data that we had cleaned up in that first notebook. And so I'm just reading it into a Snowpark data frame here. And then the very first transformation we'll do here is a min-max scalar to go ahead and normalize our caret column. And so you can see here, caret norm, it's been normalized. Second, we will use the ordinal encoder function within Snowpark ML in order to take the color and clarity columns and convert them from categorical to numeric so they are more meaningful and have some sort of ascending order to them. So finally, just to illustrate, we can also do one-hot encoding. And so in this case, I'm taking all of our categorical columns, the cut, color, and clarity, and one-hot encoding them. So you can see they've been outputted. So there's a column for each of the categories, and it's been encoded with either a 0 or 1. So now we're finally ready to build out a full pre-processing pipeline. I've laid out kind of all the categorical columns and all the categories associated with each of the columns here. And now I define the pipeline here and apply it to my initial data set here. So as you can see, all of my pre-processing has been done. All the additional columns have been now added. And I can go ahead and also save this pipeline object if I want to use it later down the line or for a different project as well. So I just save it to one of my stages here. Now that we have done all of our feature transformations, we can go ahead and do a little bit of data exploration. So we can go ahead and see what features are correlated with each other. And so we can use Snowpark ML's correlation function to better understand the relationships. And we can also visualize it, so it's much easier to understand. So we can see that carrot and price here are very highly correlated, which makes sense. So we can even look at them a little bit closer. And we do see a pretty strong relationship there. So let's move on to the third notebook now, the final part. So in this notebook, we're going to train our XGBoost model using all of the feature transformations that we did before. And then we're also going to show you how to deploy the model and perform model inference with it. So as before, I'm importing all the necessary libraries. Here, I'm actually importing XGBoost from Snowpark ML, as well as grid search. So we'll do some hyperparameter tuning with it. And then I'm also importing the model registry for deployment. Let's go ahead and establish the connection to Snowflake again and load in our input data. So as before, now I'm applying that pre-processing pipeline that I built earlier. And I'm applying it to my training and test data sets. So after I split my data sets, I can now use that same pipeline object to transform both. So that's done. And now I can illustrate, how easy it is to build a quick model. So here I'm building an XGBoost regression model, fitting it to my training data set, and then just showing kind of what the predictions look like. And here we go. So we see a predicted price has been added. And we can even analyze the results using Snowpark ML's mean absolute percentage error function. So now we have our price, our actual price and our predicted price, and we have a mean absolute percentage error calculated between the two. So we can also go ahead and visualize the results by plotting it. And we see a pretty good correlation between the actual and predicted price. So our model did a pretty decent job of predicting price here. But let's take it a step further and use Snowpark ML's grid search CV function to find our most optimal model here based on the optimal set of parameters. So we can pass in a set of different number of estimators, as well as a set of different learning rates, and see which combination gives us the best mean absolute percentage error value, which is how we're analyzing the accuracy of this model. And setting up this function is fairly straightforward as well. We just pass in the estimator here. We want to make sure we're using all the threads in our node. And then we just pass in all of the input columns, as well as our label, which here is price, and then what our output column should be named as. And then we just run the fit and wait for it to give us the optimal model. So this will take about 2.5 minutes to run. So now it's ready. We can take a look and see what our best estimator is. So as we can see, the parameter of an estimator is being 500 and the learning rate being 0.4 gives us the most optimal model for us here. We can also visualize the grid search results just to see how varying the learning rate and the number of estimators varies our MAPE values as well. And so continuing on, same as before, we can take a look to see how our predicted price versus our actual price looks like using our optimal model, and then look at a plot of the two as well and see how the correlation looks now. So as we see now, our mean absolute percentage error has improved a bit as compared to before. So we're good to go now, and visually it's looking good as well. So let's go ahead and now deploy our model. So before we do that, let's save some important metadata first. So some of the different hyperparameters, as well as the accuracy metric, the mean absolute percentage error. So we can log this along with our model. And once we have that, we can create our model registry object to log our model, and then pass in our evaluation metric as a part of the metadata that will be logged as well. Finally, let's confirm that it was added correctly. And yes, I see my model here, and I see the various metadata associated with it, as well as the metric that we tagged here. So now we're ready to deploy. So we use the model registry's deploy function to deploy the model that we logged above. And let's just confirm it got deployed. Yes, it did. It shows up when we look at our list deployments function here. And now we're ready to use this deploy model to perform inference. So again, I call my model registry object here based on what I named my model and my model version. And then I can directly use the predict function from the model registry object in order to run my prediction on my test data frame. And as you can see, my predicted price got added to my test data frame, and now we're ready to do some cleanup as well.